Hey, let's take a look at your MT6 LT6 affirmation right now. If we take a look at this first problem, it says Rachel does a weekly exercise program consisting of cardiovascular workout and weight training. Each week she exercises for at least 8 hours. She spends at most 5 hours on cardiovascular, and she spends at most 11 hours on weight training. Let X be the time in hours she spends in cardiovascular. So I'm going to highlight that so they correspond. And then Y is going to be the time that she does weight training. We want to shade the corresponding regions. Well, we have to write a system of inequalities here. First off, it says she spends at least 8 hours doing her exercises. So we're going to say X plus Y has to be greater than or equal to 8, because she's going to spend at least 8 hours exercising total. She's going to spend at most 5 hours doing cardiovascular. So X is going to be less than or equal to 5. She spends at most 11 hours in weight training, so Y is less than or equal to 11. Now we're talking exercise here, so she can't exercise a negative number of times, so we're going to say X has to be greater than 0 and Y has to be greater than 0. I kind of did that by default when I made this graph. I just put it in the first quadrant. So let's label our graph here. We'll graph our first one. X plus Y is greater than or equal to 8. So we know our x-intercept is 8, our y-intercept is 8. My boundary line is going to be a solid line. And I'm going to shade above the line because it's greater than. Let's make this a little bit thicker so I can shade a little bit quicker for you. I didn't notice this on your graph that you did. Okay, then we're going to have X is less than or equal to 5. So that's a vertical line going through 5. And I'm going to shade less than, so that means I'm going to shade to the left of that line. So right here is going to be my double shaded region. And by default, I graphed X is greater than equal to 0 also, just by doing in the first quadrant only. My third line, Y, is less than or equal to 11, so I'm going to have a horizontal line going through 11. And since it's less than, I'm going to shade beneath that, so my triple shaded region is going to be this region right here. And there's your solution. I didn't have to graph y is greater than equal to 0 because of my diagonal line there going through 8. But if when you graph this on the computer, if you end up in the negatives, you have to throw in the x is greater than 0 part. Okay, now let's check these. Some of these are right, some of these are wrong. I left your answers here so we can tell. Let's start. Remember, it goes x and y. So I'm going to start with my first ordered pair, 1 and 13. Is 3 times 1 minus 2 times 13. Does that equal to negative 8? Well, 3 times 1 is 3. 2 times 13 is negative 26. Or 2 times 13 is 26. 3 minus 26 is negative 23. Does negative 23 equal negative 8? No, it doesn't. You don't have to check the other solution. The answer is no. If the first equation is not true, then it's not a solution. Let's check the other system. Let's do the second one now. Let's do 3 times 0 is 3 times 0 minus 2 times 4. Does that equal negative 8? Well, that's 0 minus 8, which is negative 8 equals negative 8. So that one checks. Now, just because that one checks, let's check the second one. Y equals 9x plus 4. So does 4 equal 9 times 0 plus 4? Well, 4 equals 4, doesn't it? They're both true, so that one is a solution. Let's try the next one. Does 3 times negative 6 minus 2 times negative 5, does that equal to negative 8? Well, 3 times negative 6 is negative 18. A negative times a negative is a positive, so plus 10. Negative 18 plus 10 is negative 8, so negative 8 equals negative 8. That checks. Let's check the second equation then. Does negative 5y, does that equal to 9 times negative 6 plus 4? Well, 9 times negative 6 is negative 54, plus 4 is negative 50. That's not true. If the first equation is true and the second equation is true, you are correct. That's not the second equation is false. You're correct. That's not a solution. Okay, let's check the third, or the last line here. So we're going to do 3 times 2 minus 2 times negative 7. Does that equal to negative 8? Well, 3 times 2 is 6, and negative times a negative is a positive 14. 14 plus 6 is 20. That does not equal negative 8, does it? So that one should have been no. Okay, let's take a look at this system you're supposed to graph here. We have y is greater than or equal to 5x minus 3. So first off, your y-intercept is at negative 3. So let's put my y-intercept at negative 3. My slope is 5, so I'm going to go up 5 and over 1. Notice it's greater than or equal to means it's going to be a solid boundary line. So I'm going to graph a solid line going through those 2 points. And since it's greater than, I'm going to shade above my boundary line. Vertically above means I'm going to go above my line. Here's the boring part you can maybe fast forward to. Now let's graph the second inequality, negative 2x plus 3. So this time my y-intercept at the positive 3. I'm going to go down 2 and over 1. This time it's a dashed line. And I'm going to shade below that line. Well, I'm going to shade below that line in the area I've already shaded. So here is your solution that I was looking for. This is the part you should have clicked on. And that's your solution. That's what your graph should have looked like.